This is question number 12 of homework 14. Consider a bank with the following balance sheet. So on the asset side, you have the required reserves, excess reserves, loans, and you have liabilities, checkable deposits, bank capital. One thing you can note is that here bank capital is a negative number. So that means actually the bank is not in a good shape. In other words, the bank is actually in bankruptcy. You can note that. Assume that required reserves are 8%. So required reserves should be a percentage of the checkable deposits, 8%. In order to avoid insolvency, so right now the bank is actually insolvent. Regulators decide to provide the bank with $29 million in bank capital. So once the regulators inject $29 million into the bank capital, you can see that this is above the negative 13. So when you add 29, the total bank capital will become a positive number. So that can avoid the insolvency. Assume that bad news about mortgages is featured in the local newspaper, causing a bank run. As a result, 35 million in deposits is withdrawn. So when the regulators inject $29 million into the bank, so negative 13 plus 29, so that gives you a positive number. But at the same time, checkable deposits will decrease because $35 million in deposits is withdrawn. So this will be decreased by $35 million. Show the effects of the capital injection and bank run on the balance sheet. So first, as we explained, we can determine the checkable deposits and the total bank capital after the capital injection. So probably the second part is relatively easy. New capital is negative 13 plus 29. So that will give me 29 minus 13. So that's 16. So this is 16. And checkable deposits, as we just explained, the initial checkable deposits is $140 million, and 35 million of that will be withdrawn. So the new checkable deposits will be 140 minus 35. So that can give me 105. And then required reserves is a percentage of the new checkable deposits, and required reserve ratio is 8%. So the required reserves will be 8% multiplied by 105. We can just use a let me use Excel, get that number, 105 times 8%. So we have to note the rounding requirement. You can see that here, round your responses to the nearest whole number. So whole number means that there shouldn't be any decimal place, or we should keep the integers for their answers. So that means we should round to 8, round down to 8. Okay, so required reserves will be $8 million, and I think the other amounts, the loans will not change because the setup doesn't mention anything about the loans. So loans will be the same, 75. And what about excess reserves? So this amount, excess reserves, will change in order to balance this balance sheet. So balance sheet means that assets has to equal to liabilities. So you can see that on the asset side, we have the required reserves and we have the loans, and on liability side, the two items here are both known. So though the only unknown item is on the asset side, which is the excess reserves. So we can solve out these assets, unknown excess reserves. by using the balance sheet identity. Total liabilities, checkable. This is miles 5, and bank capital, this is 16, and total assets that required reserves. So let me move this to the right to have more space. This is 8, and excess reserves, this is unknown. And finally, loans will not change. So this is 75. So let me use 75. So this is the checkable deposits. Here is 105, 105, and back capital 16. So the total, which should be the sum of this, sum of the checkable deposits and back capital on the right hand side. So that gives me 121. And the total here is some amount, which is, we have this x unknown, right? So this is a unknown amount. So you can set up an equation and solve out that, which it should be also very straightforward to do. So if I open OneNote, I can do that pretty straightforwardly. So you can see that the assets is 8 plus this, that makes you, this is x. So x plus 75. I'm using mouse, so writing is not very smooth, so excuse me for that. And so this is the total assets, and that equals total liabilities. Total liabilities 121. So from that you can move 8 and 75 to the other side, and then you can solve out this x. X equals 121 minus 8 minus 75. So this gives me, you can further use Excel, get that number 1. So that gives me 38. So 38. So that this unknown excess reserves is 38. So let me double check. Now the sum of the total assets is simply required reserves, excess reserves, and unknowns. So that gives me 121. You can see that the sum of the total assets here is 121, and the sum of the total liabilities is also 121. So this equation is balanced. So that's one way we can solve out this unknown x, which is excess reserves. Another way is simply to use Excel. By using Excel, I first assume any arbitrary number. You can see that if I assume the excess reserves is only $5 million, obviously, since this is arbitrary number, so that will not make the balance sheet to be balanced. So right now the total assets is only 88, but the total liabilities is 121. So this is not balanced yet. But let me start from there and use the data and what if and goal-seek function to solve out this equation. So to use this goal-seek utility, I set the goal, which is the total assets here, to be equal to the total liabilities, because the total liabilities is known, so I have to set this to be 121. I cannot equal this to be a cell value. That's the rule by Goldsick. So I have to input a specific number, and fortunately this specific number is given, right? The total liabilities is 121. So that's my target, that's my goal. And the variable here is this excess reserves. So by changing cell is this excess reserves. So now click OK. So you see that now basically this tells me if excess reserves is 38, then this goal, which is the total assets, will equal to 121, which is the total liabilities. And that's the same as what we found by using the algebraic. So now I have found out this 38. So that's the first part of this question. Check my answer now. Okay, that's good. So let's go on. Was the capital injection enough to stabilize the bank? The bank now has a capital ratio of, so what's the capital ratio? Capital ratio is basically the ratio of the bank capital to the total assets or the total liabilities, because these two numbers are the same. So basically the bank capital here is 16 and the total liabilities is 121. So that means my bank ratio, my capital ratio is 15 or 16 divided by 121. So that's we have to be careful about the rounding requirement here. Round your response to 1 decimal place. So I should keep this. And also because this is already in percentage sign, so it's better for me to format the cell just to and put this into a percentage number and only keep 1 decimal place. So that gives me 13.21, 30.2%, 30.2. And the bank is well capitalized, I believe. So how do you determine whether this is well capitalized? And that information actually you can find from the book or from my PowerPoint lecture slides. So if you click on my PowerPoint lecture slides, chapter 10, you can find that the same slides from my lessons, weekly lessons, here. So this is the same as what I just clicked on my hard drive. So open that. And you can go to the where capitalized capital requirement. So you can see that this is on page 13 of the slides. There are two forms. Government imposed capital requirements are another way of minimizing moral hazard at financial institutions. Two forms based on the leverage ratio. Leverage ratio is basically the same as capital ratio, which is calculated. To be classified as well capitalized, a bank's leverage ratio must exceed 5%. So the cutoff ratio here is 5%. And we can see that here the bank is 13.2%. So that's over the 5% cutoff number. So that means this bank is well capitalized. Good job. And if the bank regulators decide that the bank needs a capital ratio of 15% to prevent further runs on the bank, how much of an additional capital injection is required to reach the 15% capital ratio? Bank regulators. So this question is asking, right now the capital ratio is 13.2%, but the target is 15%. So how much more capital does the bank need in order to meet this target capital ratio requirement. So that's basically what the question is asking. And to solve this question, we can also use one of the two ways. First, we can use the algebra. Go back to this question. Now let me add one more. One more item here is additional capital. So this is unknown, right? It's x or y. Let me use y. This is y. And when you put additional capital here, and because the checkable deposits doesn't change, so that means required and reserve ratio obviously also doesn't change, right? It's 8%. So required reserves also doesn't change in this case. And so the knowns don't change on the asset side. So in order to balance this equation, remember the right-hand side is, because of this additional capital, it will increase by y. So if you don't change the left-hand side, the equation, the balance sheet will not be balanced. So as we just analyzed, the only thing that can change is this excess reserves. Remember, we used these excess reserves to balance this balance sheet in the previous step. Now we also need to use this excess reserves to balance this new equation. But now we can see that this will be 38 plus y. All right, so that's the new, because of this additional capital. So in order to balance, initially the equation is balanced, as we just calculated. Now with this new additional capital, you also need to add y to the left-hand side. So, and then as we just explained, you can only add to the excess reserves. And because the initial excess reserves is $38 million, so that the new excess reserves has to be 38 plus y. So that's basically the based on the information. Now we can set up the equation, because with this additional capital, the new level of capital is 16 plus y, right? So that's the new level of capital. So the equation will be new capital. This is new capital. New capital is 16 plus y, right? So that's, and what about the new assets? Yeah, the new assets, it will be initial total assets or total liabilities plus this y, right? The new assets. New assets is initial total assets or total liabilities plus this y. Yeah, some of you may be tempted just to use this new capital divided by the original total assets, but that's incorrect. We also need to add y to the original asset, and that's our new asset. So, and with this, the new ratio will be 16 plus y over 121 plus y. And the setup tells us we need to make this new ratio to be 15%, right? 15%. So this will be 15%. Now you can see that this is one unknown and this is one equation. So you can solve out this equation. How can you do that? You can multiply. First, let me use a decimal number instead of the percentage, just for easy of viewing. So we first multiply both sides by this denominator of the left-hand side, and that can get rid of the denominator, right? So now the left-hand side will become just in the numerator, 16 plus 1. And then that equals the right-hand side when it multiplies by the denominator here, 121 plus y, and this will give me 0.15 times 121 and plus 0.15 times y, right? When I use the distribution rule. So now the next step is simply to combine the terms involving y. So we have a y on the left hand side, we have a 0.15y on the right hand side. So why don't we move this 0.15y to the left hand side and then move 16 to the right hand side, and that will become, remember, we will move the terms to the other side, we have to change the sign. Right, so now this will become negative minus 0.15 y, that equals 0.15 times 121 minus, because this is positive, when you move when we move 16 to the other side, and you have to change the sign. So now we can combine the terms. Remember, y basically is equal to the 1 minus 1 times y. Why do I write the term like that? Because I want to combine the coefficient involving y. So now this will be 1 minus 0.15 times y, and that equals this whole chunk here. So for the sake of time and space, let me just use that symbol. So now I can just divide both sides by this 1 minus 0.15 to solve out this y. So now the numerator will be this whole chunk here, 0.15 times 121 minus 16. And this will give me divided by 1 minus 0.15. So the final step is simply to put everything into Excel and solve out this number. So let me just use 0.15 times 121 minus 16 over 1 minus 0.15. So now go back to the setup and notice the rounding requirement. So round your response to 1 decimal place. So I have to keep 1 decimal place, and that gives me 2.5. $2.5 million to reach the 15% capital ratio. So basically this question is done, but as I said, this is only one way to solve out this equation using the algebra. Another way, we can follow the similar steps as we did earlier to solve out this y. Still, but here I think we need to be a little bit smarter in order to do that. All right, remember we in order to use the goal-seek function in the data tab, what if analysis goal-seek function, we have to set a goal, a target cell, or an object cell, and the target to a value, and then this variable, basically the excess reserves. So we can assume any arbitrary number. It's start from 5. Okay, we use the 5 here. And that excess reserves, remember, why don't we use 38 plus 5, which is 43. Yeah. And then this additional capital, oh, why don't we set up the simply the this y to be as we just did in using the algebra to solve out this y. We just use this additional capital as the unknown y. Y here is 5. Obviously, that's an arbitrary number. But then, in order to balance this equation, the new this new excess reserves has to be equal 38 initial value plus this additional capital, right? So now if you change this to be 6, and you can see this is still balanced. Now I need to set up the new sum. New sum will not only be the sum of these two, but including the additional capital. So this will be a sum of F6 up to down to F9. And this will be C6 to C8. That's still the same, right? Because we basically changed the excess reserves in accordance to 6. So you see that no matter what happens to the additional capital, this equation where this balance sheet will always be balanced. And that's because I made it that way, right? Excess reserves is the initial value. And initial value already made the balance sheet balanced, and add this additional capital. So that will obviously make the balance sheet always be balanced. And that's the goal. So now what is my target? What is my object? Object is the capital ratio. Remember, that's our target here, right? The capital ratio basically is the sum of this original capital plus this additional capital and divided by the total assets or total liabilities, right? So that's my capital ratio here, and that is my object. And so I just need to set this equal to the target ratio, which is 15%. Right? So now I have a goal. And remember, as we said, this goal cannot be a cell value. It has to be a specific number. And that's why I write the capital ratio this way. A capital ratio, that's my target. And to value 15% by changing what? By changing the additional capital here. And then, okay. All right, so you see that now Excel has basically calculated this additional capital in order to meet the capital ratio requirement. A target value is 15%, and the current value is there's a slight difference, but I think that's within the tolerance level. Where additional capital, when the additional capital is equal to $2.5 million, and basically this capital ratio will meet the target. And you can see that that's the same value as we just found out by using algebra.